We'll be talking today about gaming in the glass safe, which is about games, DRM, and privacy. My name is Ferdinand Schober, and I'm a security researcher, and I've got a strong background in games. I've done game development and game security. So let's look at the privacy aspects. The outline for my talk is, first we'll start off with some historical development, which is about the copy protection that actually DRM and everything we're going to talk about and the privacy impacts actually came from. And it's important to understand the historical development to understand where we really are at this point in time. Then we'll look at the different DRM approaches that exist at the moment. We'll do a privacy study on each of them. We'll look at some of the failure cases, which might be or might not be, depending on if you did it or not, quite amusing, and then we'll look at some of the case studies in particular and give names to things. I'll then continue with messing with the gamer, because some of these DRM systems are rather easy to mess with, and you can piss somebody off significantly, or you can get revenge if they pissed you off. And at the very end, there's something that I tossed in on a recommendation from a friend, is we'll talk about why games are actually being cracked. And there's some interesting tidbits here that basically put everything else into perspective. And then, if we still have time here, we'll do Q&A, and otherwise the breakout session is in 106. So, first of all, we've got the historical development of copy protection. One of the very first things that happened was we had floppies. And floppies were the big distribution media in the 1980s and around this time. But the problem is also floppies at that point in time were relatively cheap. I mean, they were feasible. They were cheaper than actually buying, let's say, a game. So the very simple thing that had already happened at that point previously was disk layout protection, meaning you have a very unique disk layout that your normal operating system copy routines don't understand. The application and game itself actually understands it, and therefore you can get away with this. You're basically breaking the standard to some extent. This wasn't a big hurdle for copy protection, and we'll actually see that has been done in the same way later on, because we didn't obviously learn it from a copy protection perspective. But the resolution for this is really simple. You do a nibble copy, and a nibble copy just means you're reading out the raw data and you duplicate it. So to counterbalance that, the next thing that came out was the so-called Feelis. I'll actually have a specific slide for those because I think they're really interesting. The idea behind those is that you have a physical token that you get with the game or the software. One of the pictures up here, and I'm not sure if you can see it, is a small little prism that came with a game. Really annoying to use, but you held it up and it would take some pixels that seemed to make no sense and would generate a picture that you then had a challenge and response to. So you had a lookout table that was printed out. And these are all bound on the idea, based on the idea that you have something physical that comes with the game that is hard to replicate, and therefore you need to buy the original game to actually use it. The other thing is they also give you like neat little content. But given that you can replicate most of these relatively easily, at least with today's technology, they're totally useless. The other thing that also plays into this here is that if you can remove the little bit of code that actually checks for it, then you can just play the game and don't have to worry about this. So as a side note, the Feelis in more detail, because a couple of the younger folks might not have seen this. I still remember when I had games that I actually played with this, and I really liked them. Especially in the middle we have Ultima 7, and Ultima 7 had this beautiful cloth map. And it was really nice. It still hangs on my wall, actually. But it also doubled as a lookup table, so you could figure out where something was and you needed to answer some questions. This is only effective as long as the token hard to copy. For example, on the right side here, you've got like SimCity, and that's in red because black and white printers or copy machines would not be able, quote, to copy this. These days, you take a picture of it with your cell phone and you're done. You put it into the internet and you've just voided everything. So it's completely outdated. But it's kind of nice to see that there was a part of DRM or copy protection that actually added value to the user. And this is the last time we'll actually see this, that there's added value to the user. So The next step that came along was the revolution with using CDs and later on DVDs that is then again mirrored. And that was around 1995. You had games that previously came out of floppy, now it was too big for a floppy, you came out on discs. And the CDs were, again, harder to copy in the beginning because you needed to have expensive hardware, the empty discs were relatively expensive. But again, like the same thing with the nibble copy, as long as you have a hardware that can actually read the disk and you can copy it bit by bit, there's not much to it. The tricky part here is that the game publishers and game developers, or anybody that was in this copy protection scheme, broke the CD standard, and that's where we get a lot of the discs these days that are bigger than what the original standard was envisioned to be, because they just could get away with it. And this is obviously only applies to digital media, and we see how this moves forward in a bit into the digital realm as well. A couple of years later, after everything failed with the CD protection and the duplication, people were just duplicating their CDs, the next thing that came along, which had actually been previously applied to Office software, for example, is the registration key. And very simply put, a registration key is a secret that certifies that you have actually purchased the software legitimately. And how they are done underneath the hood is there's typically some cryptographic function that has a couple of parameters that the publishers or game developers can tweak, and that will generate a sequence of valid registration keys. Now, there's two problems with this approach. First of all, the registration keys can be reverse engineered if you have a lot of them, or if you can actually figure out what the checks do, because the checks have to know part of that algorithm to actually work on part of the parameters. So again, you can break this either in the brute force method, quote brute force, where you generate valid registration keys and dump them in, or you remove that little bit of code that actually checks for it. One of the games that actually used this for the first time was, as you can probably barely make out up in the picture, is Half-Life, the original Half-Life. And they used it for installation, and then later on, if you had a collision of registration keys during multiplayer, you couldn't play a multiplayer key. But it wasn't as essential and as baked in as it is these days. Now, I've been talking a lot about these techniques that you can remove a bit of code and then everything is avoided. Like you can work your way around this. So what happened really early on, like in the 1980s and even earlier, and then again in 2000, and that's why I have two numbers here, is code obfuscation. The basic idea of code obfuscation is that you make something so convoluted that it's really hard to remove it or really hard to figure out what it actually does. And pre-2000, at least in the game space, this was all mostly homebrew stuff. So people would generate their own little code pieces, they would drop it in, they would have something in their compiler chain that would do some magic, and ideally that would thwart all breaking of the software. In reality, it doesn't. And this then just moved into a greater business where people specialized on actually code obfuscation, and you have the emergent code obfuscation middleware in 2000, and that's why it's listed a second time. And the idea here is that you as a game developer, as a game publisher, you don't bother about the code obfuscation. You actually purchase this from a third party, you drop it into your compiler chain, and you're good. Well, this has a couple of problems. First of all, you've got these pieces of middleware that all do things similarly. And that actually helps as a cracker, if you're in the cracking scene, to identify what's going on and to possibly reverse engineer it faster. The other problem that you have is code obfuscation theoretically could be applied significantly stronger than it is. But it then has a significant performance impact. And since everything about games is performance, like you want to get the very last frame out of it. And I've seen this myself, code obfuscation sometimes would make it would have a feelable performance and measurable performance impact, or even worse, you would break your ability to even analyze failures in the program. So if you have crashes and code obfuscation is running, you might have no clue what just happened, because the point is that you have no clue what happened. So, but this is the state of the art. This is going on even now, and there are smarter ways of doing it, so you can still get some information out of it, at least for debugging purposes. Now, the first big category that is still applicable now. Everything up to this point is kind of like little bits and pieces that are still applied, but not a whole system. But the first real big one, it came out in 2002 and onward, and that's what I call the network DRM. And the idea is, previously we have done stuff on the machine. And since we own the machine, at least from a gamer's perspective and from an adversarial perspective, we can eventually break it. But now you bring in the network. You verify your registration key or some other properties of your machine remotely. And since you don't control, in theory, the remote machine and the remote server that checks that, you should be able to add more security here from a copy protection perspective. Well, that's not necessarily the case. Because again, you can remove these bits and pieces, and you are adding a lot of additional overhead that is problematic for the user, which I'll talk about in a bit. It just raises the bar. And this is all an arms race, as you'll see as we move along. It's just it's always a step up, and it makes it more complicated and convoluted to the gamer as well. Oh, what I actually should still say for this is also the first time that we really have to worry about privacy. Because before we have been on a local machine and there might have been changes to the local machine. Now we are sending stuff out, we are broadcasting. And at that point you actually have to start worrying about privacy. Now in 2003, this is actually a really rapid succession here. There's the so-called social DRM. And specifically, if you look at the picture, I'm talking about Steam for the 2003 date. And since then, that has emerged into a couple of other platforms. And we'll give names to those later on. But the fundamental difference between the network DRM and the social DRM is that you add what is now perceived as a social network to it. And you still have the DRM and everything cooked in, the copy protection, but you now have a user identification instead of a machine identification. And then the last little piece that came around in 2006 is not necessarily DRM, but it's an extension of this, which is interesting because it's a big money-making thing these days, and that's DLC. That stands for downloadable content, and the idea here is if you have already shelled out 60, 70 bucks for a game, we'll sell you an additional content for an additional $5, and you're probably going to purchase it because you want to know how stuff continues. But at least in the beginning it was a bit ridiculous, because the picture you see up there is the famous horse armor from one of the Elder Scrolls series, and that was literally just a texture, and I think it cost about $2 at the time, so that is kind of very blatant money making. Now let's give these systems that we have talked about names. Because you'll hear this in the news, you'll see it when you start up your games, and you might have even run into trouble with these. And these are the three categories that I'll mainly be talking about. We've got the copy protection on one side, and copy protection is partially outdated. So you might still see the names pop up, but they are not very effective, and they might be employed with other DRM systems on top of them. And I classified them roughly into the obfuscation, the CD copy, and the mixed ones, and the most successful have been the mixed ones. And by the way, this is by no means a complete list. There is way more out there. And as a little segue, it's kind of interesting, when I was researching for this, I was looking through a lot of pages and web pages of DRM and copy protection companies. And getting information from them about what their copy protection actually does is surprisingly hard. You would assume that they would advertise, hey, we have this big thing, we protect your memory, we do this and that. No, they're like red cubes, and the red cubes for some reason mean copy protection. And then there is a phone number. There isn't even an email address. I think they're so scared and paranoid at this point that they're going to just get mail bombed or whatever, that they don't put information online anymore. And I didn't really feel like calling them up and explaining to them that I'm actually talking about them. I don't think that would have gone over very well. Okay, back to the topic at hand. So we have the network DRM here that is basically what's more or less the state of the art for a lot of games out there. And three in particular are really popular with games these days, and they're actually employed even on top of the social DRM. So you might have two layers on DRM, which doesn't necessarily increase security, as we all know, but it just increases annoyance. And my favorite one on there is actually the Target, and that's just because I don't know how to pronounce this stupid thing, because it's a French company that makes it, so I want to pronounce it in French, but it doesn't look like it has an accent or anything in there. And we'll hear about this more in detail, why this